Jupiter, more than a giant, a force. Jupiter has always felt familiar. A giant in the night sky. Bright, steady, predictable. For centuries, it was just another planet. Bigger than the rest, but not fundamentally different. A gas giant. A massive ball of hydrogen and helium. A scaled-up version of something we thought we understood. But that understanding was incomplete. Because Jupiter is not just bigger, it is different. Radically different. It contains more than twice the mass of all the other planets combined. It dominates the solar system in a way no other planet does. Its gravity shapes orbits. Its presence influences everything around it. And yet, for a long time, we simplified it. We called it a protector, a shield that deflects comets and asteroids away from Earth, a guardian sitting at the edge of the inner solar system. That idea was comforting. But it wasn't the full story, because Jupiter doesn't just protect, it disrupts. It captures, it redirects, it accelerates, and sometimes it sends things toward us. The more we study Jupiter, the clearer it becomes. This is not a passive giant. It is an active force. Its atmosphere is violent. Its radiation is lethal. Its magnetic field is enormous. And deep inside, we still don't know what it really is. Not completely. Is there a solid core? Is it diffuse? Is it something else entirely? Even now, with modern spacecraft and advanced instruments, Jupiter refuses to fully reveal itself. Because it is not just a planet, it is a system. A complex, dynamic structure that behaves in ways we are still trying to understand. What we once thought was simple turns out to be layered, chaotic, and far more powerful than we imagined. Jupiter is not what we thought it was, and the deeper we look, the worse it gets. Jupiter is not just large, it is overwhelming. If you took every planet in the solar system, Mercury, Venus, Earth, Mars, Saturn, Uranus, and Neptune, and combined them, Jupiter would still be more massive. It holds over 70% of all planetary mass in the solar system. That scale is hard to grasp. You could fit more than 1,300 Earths inside Jupiter. And yet, it's not solid. It's made mostly of hydrogen and helium, the same elements that make up the Sun. That's why scientists sometimes call Jupiter a failed star. Because in another scenario, with just a bit more mass, it might have ignited, might have become something very different. But even as a planet, its size changes everything. Gravity depends on mass, and Jupiter has a lot of it. Its gravitational pull shapes the architecture of the entire solar system. Asteroid belts, comet paths, orbital stability. Jupiter influences them all. The asteroid belt between Mars and Jupiter never formed into a planet. Not because it lacked material, but because Jupiter's gravity kept disrupting it, preventing accumulation, breaking apart formation. Even distant objects feel its presence. Long-period comets, originating from the far edges of the solar system, can be pulled inward by Jupiter's gravity. Some are captured, some are flung away, some are redirected toward the inner planets. Jupiter doesn't just sit in its orbit, it interacts constantly, and its size amplifies everything it does. But there's another consequence of being this big: pressure. Deep inside Jupiter, pressure increases to unimaginable levels. Hydrogen, the simplest element in the universe, is forced into exotic states. At certain depths, it becomes metallic hydrogen, a form of matter that conducts electricity. This is not something we see naturally on Earth. Jupiter is so massive that it creates conditions that shouldn't exist on planets. And that matters, because those conditions power everything else. Its magnetic field, its radiation belts, its internal heat. Jupiter is not just a bigger version of Earth, it is a different kind of world, one that operates under different rules. And those rules make it far more powerful than we once realized. Jupiter looks like a planet, but in many ways, it behaves like something else. Because at its core, Jupiter is made of the same ingredients as a star: hydrogen, helium, the raw materials of stellar formation. That raises an obvious question. Why isn't Jupiter a star? The answer is mass. To become a true star, an object needs enough gravity to compress its core to the point where nuclear fusion begins, where hydrogen atoms fuse into helium, releasing enormous amounts of energy. That threshold is high, roughly 80 times the mass of Jupiter. Jupiter falls far short of that. It has only about 1/80th of the mass needed to ignite, so it never became a star. But it didn't remain completely inactive either, because Jupiter still generates heat. In fact, it emits more energy than it receives from the sun. That shouldn't happen for a simple planet. But Jupiter is not simple. As it formed, gravity compressed its interior, converting gravitational energy into heat. That process didn't stop. Even now, billions of years later, Jupiter is still slowly contracting, very slowly. And as it does, it continues to release energy. This is known as the Kelvin-Helmholtz mechanism. It's the same process that powers young stars before fusion begins. So while Jupiter never ignited, it is still radiating energy from within. It glows, not in visible light, but in infrared, a faint internal heat, a leftover from its formation. And that heat drives its atmosphere. Jupiter's storms, winds, and turbulence are not powered only by sunlight. They are fueled from below, from a planet that never fully cooled. There's another category of objects that sit between planets and stars. They're called brown dwarfs. Brown dwarfs are often referred to as failed stars because they are too small to sustain hydrogen fusion, but large enough to fuse heavier isotopes like deuterium. Jupiter is smaller than even the smallest brown dwarf, but it sits on the same spectrum, a continuum of mass where planets blend into stars. And Jupiter is right at the edge of that boundary, close enough to share characteristics, far enough to remain a planet. But imagine if it had just a little more mass. If Jupiter had formed with 10 or 20 times its current mass, it might have become a brown dwarf. If it had formed with 80 times its mass, it would be a star. The entire solar system would be different. Earth might not exist. Life might not exist. Jupiter is not a star, but it is not entirely a planet in the way we think of planets. It is something in between. A massive object with star-like properties that never crossed the line. And that makes it unstable in a different way. Not exploding, not collapsing, but constantly radiating, evolving, and shaping everything around it. Jupiter didn't fail to become a star. It became something else. Something powerful enough without ever igniting. If Jupiter were just massive, it would already be extraordinary. But its atmosphere makes it something else entirely. Because Jupiter is not calm, it is violent. And nowhere is that more visible than in the Great Red Spot. A storm larger than Earth, spinning for more than 300 years, possibly longer. On Earth, storms form, grow, and dissipate. They last days, weeks at most. Even our largest hurricanes eventually lose energy. Jupiter's storms do not. The Great Red Spot is a massive anticyclone, a high-pressure system rotating counterclockwise in Jupiter's southern hemisphere. Winds inside it reach speeds of over 400 kilometers per hour. Clouds swirl endlessly. Layers rise and fall. And yet, it persists. Why? Because Jupiter has no solid surface. On Earth, storms lose energy when they interact with land. Friction slows them down. Heat sources disappear. Jupiter has no land, no ground to disrupt its storms. Just layers of gas, moving, mixing, feeding the system. And there's more. Jupiter generates heat from within. That internal energy rises through the atmosphere, fueling convection. Warm material rises. Cool material sinks. This constant movement powers storms from below, not just from sunlight above. So Jupiter's storms are not temporary. They are sustained, driven by a planet that never stops moving. But the Great Red Spot is only one example. Jupiter's entire atmosphere is divided into bands, light zones, and dark belts, each moving at different speeds. These bands create jet streams that wrap around the planet. Where they meet, turbulence forms. Storms emerge, merge, split, disappear, and new ones form. It is a system in constant motion. Lightning has been detected within Jupiter's clouds. Powerful electrical discharges deep in the atmosphere. Some storms produce flashes far more energetic than those on Earth. And then there are the smaller vortices, storms that interact with the Great Red Spot itself. Some are absorbed, some bounce off, some are torn apart. The Great Red Spot has even been shrinking over time. Once large enough to swallow 3 Earths, it is now smaller, though still enormous. Which raises another question. Will it disappear? Or is it simply changing? Jupiter's atmosphere does not behave like anything we see on Earth. It is deeper, more energetic, more chaotic. And because we cannot see beneath the cloud tops, we don't fully understand what's happening below. How deep do these storms go? How are they sustained over centuries? We are still trying to answer those questions. But one thing is clear. Jupiter is not a quiet giant. It is a world where storms do not end. A planet where the atmosphere is not weather, but a permanent state of motion. Jupiter's storms are violent, but they are nothing compared to what surrounds the planet. Because Jupiter is not just dangerous on the outside, it is deadly in ways we cannot see. Jupiter has the most powerful magnetic field of any planet in the solar system. Not slightly stronger than Earth's, thousands of times stronger. This magnetic field creates a vast region around the planet called the magnetosphere. It is enormous. If it were visible in the night sky, it would appear larger than the moon. And inside it is radiation, extreme radiation. Charged particles, electrons and ions, are trapped by Jupiter's magnetic field and accelerated to incredible speeds. These particles spiral along magnetic field lines, forming intense radiation belts around the planet. Similar to Earth's Van Allen belts, but far more powerful. The energy levels inside Jupiter's radiation belts are so high that they can destroy spacecraft electronics in hours. No human could survive exposure there. Not for seconds, not for minutes, instantly lethal. And the source of this radiation is not just the sun, it's Jupiter itself. One of the key contributors is its moon Io. The Io is the most volcanically active body in the solar system. Its surface is covered in erupting volcanoes, spewing sulfur and other materials into space. That material becomes ionized, turned into charged particles, and Jupiter's magnetic field captures it, accelerates it, feeds it into the radiation belts. Jupiter becomes a particle accelerator on a planetary scale. The result is a system where radiation is constantly generated, trapped, and intensified. The closer you get to Jupiter, the worse it becomes. Spacecraft have to be carefully shielded. Even then, their lifetimes are limited. NASA's Juno mission, currently orbiting Jupiter, follows a highly elliptical path to minimize time spent in the most dangerous regions. It dives in, collects data, and escapes, because staying too long is not an option. But the radiation doesn't just stay near Jupiter. It interacts with its moons. Europa, Ganymede, and Callisto are all exposed to varying levels of this radiation. Surface materials are altered. Ice is chemically modified. Any potential life beneath the surface of these moons would have to be shielded from above. Jupiter's magnetic field is not just a feature. It is a weapon. Invisible, constant, relentless, and it transforms the space around the planet into one of the most hostile environments in the solar system. Jupiter doesn't just dominate with gravity, it dominates with energy. And that energy makes it far more dangerous than we once imagined. For a long time, Jupiter was seen as a protector, a giant shield, a planet so massive that it deflects comets and asteroids away from the inner solar system, protecting Earth from impacts. And sometimes that's true. Jupiter's gravity can capture incoming objects. It can pull them into its orbit, even absorb them. In 1994, we saw this happen. The comet Shoemaker-Levy 9 collided with Jupiter, breaking apart and slamming into the planet in a series of massive impacts. Each fragment exploded with the force of nuclear weapons, leaving dark scars on Jupiter's clouds. It was a reminder of what Jupiter can intercept. But that's only one side of the story, because Jupiter doesn't just remove threats, it creates them. Its gravity is so strong that it can redirect objects, pulling comets from distant regions and sending them inward. Some of those objects are ejected from the solar system entirely, but others are placed on new trajectories, and those trajectories can cross the orbits of inner planets, including Earth. Jupiter acts like a gravitational slingshot. It accelerates objects, changes their paths, sends them where they wouldn't have gone otherwise. The asteroid belt is a perfect example. Between Mars and Jupiter lies a region filled with rocky debris. Why didn't that material form a planet? Because Jupiter's gravity kept disturbing it, preventing it from clumping together, breaking apart, forming bodies. Even today, Jupiter's influence creates gaps in the asteroid belt, regions where objects cannot maintain stable orbits. And occasionally, fragments from that region are nudged inward, toward us. So Jupiter is not just a shield, it is also a source of instability, a planet that both protects and threatens, that both absorbs and redirects. Its role is not simple. It is complex, dynamic, and sometimes dangerous. Jupiter doesn't just sit at the edge of the inner solar system. It shapes it, for better and for worse. For a planet this large, we should understand what's inside it. But Jupiter refuses to be clear. Unlike Earth, we cannot drill into it. We cannot place instruments on a surface, because there is no solid surface. Everything we know about Jupiter's interior comes from indirect measurements, gravity, magnetic fields, pressure models, and those measurements tell us something unsettling. We don't know what Jupiter's core really is. For decades, scientists believed Jupiter had a solid core, made of rock and metal, surrounded by layers of hydrogen and helium. Simple, structured, predictable. But newer data, especially from NASA's Juno mission, has changed that picture. Jupiter may not have a well-defined core at all. Instead of a solid center, it may have a diffuse core, a region where heavy elements are spread out, gradually blending into the surrounding layers. Not solid, not liquid in the way we understand, something in between, a blurred boundary. This suggests that Jupiter's interior has been mixed, possibly by a massive impact early in its history, a collision large enough to disrupt its internal structure. Not destroy the planet, but scramble it. Another possibility is that extreme pressures inside Jupiter create states of matter we don't fully understand. At depths thousands of kilometers below the clouds, hydrogen is compressed into metallic form, conducting electricity like a metal. Deeper still, temperatures and pressures rise beyond anything we can replicate on Earth. Materials behave differently. Boundaries dissolve. Jupiter is not layered in neat, clean shells. It is complex, gradient, dynamic. And because we can't see inside it directly, we are left with models and questions. Does it have a core? Did it ever? Or is Jupiter something else entirely? A planet without a clear center. A world where structure itself is uncertain. Jupiter is massive, but it is also mysterious. And at its core, we still don't know what we're looking at. Jupiter is not just a planet. It is a system. Orbiting it are more than 90 moons, a miniature solar system bound to a single world. Some are small, irregular fragments, captured asteroids, broken remnants, but others are worlds in their own right. Ganymede, the largest moon in the solar system, is bigger than Mercury, It even has its own magnetic field. Europa hides a vast ocean beneath its icy surface, a potential environment for life. Io is covered in volcanoes, constantly erupting under the influence of Jupiter's gravity. Each of these moons is shaped by Jupiter. Its gravity stretches them, heats them, pulls them into complex orbital resonances. Energy moves through the system. Io's volcanic activity feeds charged particles into Jupiter's magnetosphere. Europa's ocean may be kept liquid by tidal heating. This is not a passive arrangement. It is interactive, dynamic. Jupiter doesn't just have moons. It controls them. It powers them. It creates conditions that would not exist otherwise. And then there are the rings. Faint, thin, almost invisible, nothing like Saturn's, but still present. Even here, Jupiter forms structures. The planet's influence extends far beyond its clouds. It builds a system around itself, a gravitational domain where multiple worlds are connected. Jupiter is not just part of the solar system. It is a system within it. Jupiter has long been called Earth's guardian, a massive planet sitting beyond Mars, shielding the inner solar system from dangerous objects. And sometimes that's true. It captures comets, deflects debris, absorbs impacts that might otherwise reach us. But protection is only part of the story, because Jupiter doesn't just remove threats, it also creates them. Its gravity pulls objects from distant regions, from the outer solar system, from the asteroid belt, and changes their paths. Some are sent outward, but others are sent inward, toward Earth. Jupiter is not a wall. It is a filter, a system that redirects objects in unpredictable ways. Without Jupiter, Earth might face fewer impacts, or more. We don't know for certain. What we do know is this: Jupiter is not purely a protector. It is an active force, one that shapes the environment we live in, for better and sometimes for worse. Jupiter is not what we thought it was. Not just a giant, not just a protector. It is a force, a planet that bends gravity, fuels endless storms, and surrounds itself with lethal radiation. A world with no surface, no clear core, and no simple explanation. It shapes the solar system, disrupts it, protects, and threatens. Jupiter is not calm. It is powerful. And the more we learn about it, the clearer it becomes. It's not just bigger than everything else. It's more dangerous. What do you think? Comment.